Hey sixth graders, we are going to be taking a look at the surface area of cylinders. So this can be rather confusing because there are a lot of parts to the surface area of a cylinder. So hopefully my demonstration today will help a bit. So remember, the surface area of an object is the area, the area around the three-dimensional object. So we've taken a look at some examples like boxes, like cereal boxes or tissue boxes. And so if I wanted to find the surface area, I am finding the area of all of the surfaces. So with a rectangular prism, we are dealing with a bunch of rectangles. So I'd find the area of this rectangle, I'd find the area of this rectangle, and this one, 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 okay? I think I did one extra. There should be 6 surfaces. So you're finding the area of each surface and then you add them all together. And we talked about this idea of nets where you are breaking down your shape and laying it flat to be two-dimensional so that you can basically create a composite figure. And in that case, you just find the area of each part and you add them all up. It helps to make it a little bit easier. So I want to talk today with you about what the net of a cylinder would be. So I figured in these crazy and scary and not so great times, why not use a Clorox bottle? This is a cylinder. Okay, so what are cylinders? Cylinders are three-dimensional objects. Again, what are three-dimensional objects? They have to have a width, they have to have some type of length or depth to them, and they have to have a height. So that has all 3 of these dimensions. It's three-dimensional, I can hold it. It's not just a flat item on a piece of paper. So with this Clorox bottle, it's a cylinder again. What constitutes this as a cylinder is that it has a circular base up top and it has a circular base on the bottom that are identical or congruent is what we call identical shapes in geometry. So we have a congruent circle up top and on the bottom, and that's what makes this a cylinder. So when we're creating our net, we need to somehow break down this three-dimensional shape and we need to lay it flat to be two-dimensional. So how can that be done? Well, let's start with the top. Okay, so the top, I see a circular shape. So if I want to eventually lay this flat onto a piece of paper, what I could do is I could peel the circular top back and I could then lay this flat. Now I'm gonna rotate this so you can see what it looks like. That means I have a circle up top. I can't break the bottom down, but if I could open the bottom up as well, I would have another circular shape. So we're definitely gonna have 2 circles because that'll be the top and the bottom. So we'll have 2 circles, one here and one over here as well. The hardest part, in my opinion, what has confused kids the most in the past is what happens with this body of the cylinder when we want to break it down. So what we need to do is we need to cut down the height of the cylinder and we need to peel it open to lay it flat. I've actually already gone ahead and done that with the label. So this isn't going to be exactly accurate because the label does not go all the way to the top and all the way to the bottom like we need it to, but this is a really good representation. So I went ahead, I took an X-Acto knife, I cut down the height. Now pretend this goes all the way to the bottom and all the way to the top. And now I am going to unwrap it and lay it flat. I'm going to hold it this way because it's a little easier to see. What shape have I just created? It is a rectangle. So your net will be a rectangle, laying flat, a rectangle with a circle on top and a circle on the bottom. Now I'm trying to do my best to juggle this here, but it would be a rectangle with a circle here and a circle on the other side. Remember, the area of circles is pi r squared. Apple pies are square at McDonald's. But let's talk about what the area of the rectangle would be, because please keep in mind we're trying to figure out surface area. So we have to find the area of the 2 circles and the area of this rectangle now. So the area of the rectangle, we know that the length will be the height of the cylinder. So this length right here was the height of the cylinder. Again, this is a little inaccurate. So that part's easy. That's going to be your height of the cylinder right there. What about this long part here? What about the width of the rectangle? Okay, so this is kind of where kids have gotten confused in the past, but I hope this clarifies. So I'm not entirely sure what that length is, what that width is, because I wasn't given that information. I want to go ahead and rewrap this up though. So you see this rectangle, I'm gonna go ahead and wrap that back up. And if you notice, it wraps up perfectly back around the cylinder, which is circular in shape. Oh, around a circle. What concept in math do we have that can describe the distance around a circle? Circumference. So the circumference of this circle, the distance around this circle, one time around, is exactly equal to the width of this rectangle. So I'm not going to give you that width of the rectangle. You have to use the circumference of the circle to use as the width of this rectangle, because they are exactly the same thing. Okay, so one last time, this width here of this rectangle that I created, so I could lay this flat, if I wrap it back around, it wraps perfectly one time around the circle, which is circumference. So we will use the circumference as the width of the rectangle. We use the height of the cylinder as the length of the rectangle. You have your length and your width. You multiply for the area of the rectangle, add that to the areas of the top and the bottom. Hopefully this helps clarify a bit. Please watch the notes on surface area of cylinders. I described that again, but I don't have a three-dimensional object as an example, so hopefully this clarifies.